Hi guys, I'm Mr. Corzine. I'm here. I'm going to try and get you through 4.3 notes, and this is graphing using intercepts. So what you see here is you get a couple of warm-up problems, and to save you some time so you don't have to hear me walk through all those, I put them up here. You can check your work with mine, but I want to make sure and focus on what today's goal is. I can translate an equation into a graph using intercepts. So if they give me an equation like y equals 2x plus 3, I can put that onto this graph using intercepts. You may or may not know what those are. I'm going to try and define that for you real quick. It's a simple concept, but sometimes we miss out on the opportunities to use them. So it's one way to graph our function. So if we go on to the next slide here, to find the x-intercept, it's the point where the graph crosses the x-axis. So if I draw a picture here, and I have my line, my function that I've graphed here, where the line crosses the x-axis, right here. If I can get my color to change. This is the x-intercept. Okay. Now I don't know what this number is, but when I make my ordered pair right here, I know I'm going to go this way on the x-axis. It's going to be x something, but I do know what this number is for my y value. It's 0. So I can be sure of that every time I have my x-intercept. I don't know what x is. I can approximate that, but my 0 and my y value is definitely 0. Okay. So the x-intercepts happen when the output is 0. That's my y value. I'm gonna put an extra little note in there. Y is 0. To find the intercept from an equation, x-intercept from an equation, replace y with 0. Okay, y, or the output, with 0 and solve for x. Okay, we're going to talk about this process a little bit later. If I go down here to my y-intercept, it's the same thing, only now if I draw my line going right through here. Now I'm focused on, for my y-intercept, where it crosses the y-axis. Okay, this is my y-intercept. And the one thing I know when I write my ordered pair for my y-intercept, I don't know what my y value is exactly. This is going to be a positive number here, but it could be anywhere on the y-axis. But my y value goes here, but I do know this number. That is 0. It is even with 0 on the x-axis. So all of my y-intercepts will be 0, comma something. All of my x-intercepts will be x, comma something. So keep that in mind as we work our way through. Looking here, given a graph, find the x and the y-intercepts. Okay, here it is on the x-axis. This is our x-intercept. Okay, that is 3, comma 0. On this graph, my y-intercept is 0, comma -2. Pretty simple. Over here, here's my y-intercept. And that is 0, comma, let's see, that's a 2 right there, so 0, comma 1. And then for the other side, I'm looking right here, here's my x-intercept, and that is -2, comma 0. So I think this is the super easy part. I don't think we need to get hung up here. However, sometimes we don't have a nice picture to show us where it's crossing. Instead, what we have is an equation. Now, that equation represents a line, and that line will cross somewhere on the graph. So we want to find, essentially, we can find 2 points. Oops, let me fix that. 2 points. Don't write this all over your paper. We're going to have to do some work. But if I can go on here and I can find 2 points, I can find this point right here and this point right here. Once I have 2 points, I can connect my 2 lines, my 2 points, and make a line with it. So that will basically tell me what my function looks like. So I'm going to see if we can do that for each one of these. y equals 2x plus 4. Here's what's going to happen. I'm going to take, and to find my y-intercept, I'm going to plug in 0 for x. So I'm going to do y equals 2 times 0 plus 4. So in this case, y equals 4 when x equals 0. Okay? So I put in my point, when x is 0, when my input is 0, y is 4. That's my y-intercept. I'm going to do the same thing again, only this time I'm going to do when y is 0, what's x? 2x plus 4. So I have to do a little bit of work here. I got to subtract 4 on both sides. So now I get 2x equals negative 4 and divide by 2. So I get x equals negative 2. When y is 0, x is a negative 2. So this is my intercept. Is this making sense now? I hope so. Well, now we'll go to this next equation. When this is 0 here, I can cancel this out, and I get negative 4y equals 24. Well, after that, I divide by negative 4 on both sides, and I get y equals negative 6. So my y-intercept is, when x is 0, y is negative 6. All right, and now I'm going to cheat, and I'm going to erase all this stuff, and you're going to have to find a spot to do it on your paper. But now instead of putting 0 in for x, I'm going to put a 0 in for y. So when I get negative 4 times 0, that just cancels out. So my new equation is 3x equals 4. I divide by 3 on both sides. I get x equals 8. So my other point is when y is 0, x is 8. So that represents my x-intercept. And this one represents my. It's pretty simple. What you want to make sure and do is don't rush too much, okay? Sometimes people get too much in a hurry and they oversimplify things. Last one, here we go. When x is 0, this is going to cancel out. That basically makes 0 is equal to 5y plus 10. So I subtract 10, and I get 5y equals a negative 10. I divide by 5 on both sides, and it's y equals negative 2. So my ordered pair is when x is 0, then y is negative 2. That's my first point. I'll cheat and do all the erasing, and then you guys have to find a spot. Let's do red this time. This time it'll be 0 here for y. So that cancels out, and now I just have negative 3x equals 10. So I divide by negative 3 on both sides. This cancels out. Now I get x equals negative 10 thirds, which I'm cool with keeping it just like this. I also could make it, what is that, 3 1/3, negative 3 1/3. Anyway, that's my other ordered pair. When x is negative 10 thirds, then, well, when y is 0, then x is negative 10 thirds. This is my x-intercept, and this is my y. In all of these, if I wanted to, I could make a quick sketch, okay? So, let's take, let's move that over here. For our first one, we have basically 0, 4, and negative 2, 0. So I could graph this real fast by just going to negative 2, 0, negative 2, 0. There's the first point. And then 0, 4. So 1, 2, 3, 4. There's my second point. I connect my two dots. Let me change colors so it looks a little better. Almost. And I make my sketch. So I basically have given a decent idea of what the line's going to look like just by finding those 2 points. Okay, I'm not going to do the other two. Let's move on to the next one. Given the intercepts, graph the line. Well, hey, this is like easier than ever. If my x-intercept is negative 7, I go to the x-axis and I go to negative 7. It should be right here. My y-intercept is 4. It's right here. And now, boom, I've graphed the line. You think there's something more to it, but there's not. This is it. the x-intercept. Well, x-intercept is 10, y-intercept is -1. Here I've got a little bit more of a shallow line. It's not perfect, but you get the idea. If I have those two intercepts, then I have a line. Scrolling on down. Have I done this yet? I did this one. Let's go to this one. Given the equation, find the intercepts and then graph them. Oh, well, they're going to make us work for it a little bit. Okay, well, when x is 0, this cancels out, and y equals 8. That's as easy as it gets. Now I'll erase. I'll do this again. When y is 0, I get 8 plus 2x. So 0 is equal to 8 plus 2x. I subtract 8 on both sides, so I get a -8 is equal to 2x. I divide by 2 on both sides. Turns out x is 4. So my other intercept is -4. Now I can draw my line to make a sketch. Same thing on the other side. Let's try when x is 0. This cancels out, so now I get 6y equals 18. That means y equals 3. I'm not modeling very good patience for you guys. But yeah, on my first point, my y-intercept is 3. I'll go back here. I'll do the same thing over again. Now this time when y is 0, that cancels out. 6 times 0 is 0. So I divide by 3 on both sides and end up with x equals 6. So I go here to the 6, and my sketch should look like something like this. Not a super straight line, but you get the picture. All right. Now here's where, and hopefully I've gotten to all these, I'm not skipping anything. Here's where it helps to imagine or use your intercepts. 3 inches of snow, in this story problem, hopefully this will make a little bit more sense. 3 inches of snow fell on the ground, and every day 1/2 inch of snow melted. The equation to represent this is y equals -1/2 x plus 3. Okay, so we're adding 3 inches. So that's getting added on every time. 3 inches of snow fell on the ground every day. Well, 1/2 of an inch melted. So that's where we subtract this 1/2. The equation to represent this is here. This is what we want to do. If x represents the number of days, right, and y represents the number of inches, I want you to think about this for a second. What if 0 days had gone by? Okay, what if 0 days had gone by? Like as in, like there's no no time had gone by for the snow to melt. All right. Well, we start off with the 3 inches of snow. So even though no time has gone by for the snow to melt, we start off with this 3 inches on the ground. That's the deepest that the snow could be, right? But then we're going to see it decrease as time goes on. That's basically going to go down like this because it's not 3 inches falling each day. It's 3 inches falls initially, and then every half day it goes down. So this is the max right here. When no time has gone by, we're at 3. Well, what's the other 0 that we can have? The other 0 is, well, when is all the snow gone? Okay, so when is it that the total amount of snow is going to be 0? Okay, that means our x-axis. So I have to figure that out. That means I subtract 3 on both sides, and I get, and I'm going to run out of space here. Basically, I have -3 is equal to -1/2 x. Well, then I have to multiply times the reciprocal. I basically multiply times a -2, cancel this out. I multiply times a -2 over here, and I get x equals 6. So it's actually after 6 days, which makes sense, 1/2 inch every day. cover 3 inches. It will take 6 days. So I just come up with these two, and I draw my straight line between them. Once I have those 2 days, and that hopefully I use a ruler or something to make it clear. Well, now I have all of these points along the way that I could use for any time in between. So those two intercepts help me set up a whole series of points that I don't necessarily have to make a table and graph it all out. I just have to find the intercepts. I hope that this is becoming clear for you. As you use the intercepts more, it should make more sense. You guys are going to do the 4.3 worksheet. It's actually 2 pages. One of them is double-sided and one of them is just one side. So with whatever time you have left here today, go ahead and finish work on your homework, and I will see you tomorrow.